Space travel is the most exciting and challenging adventure humanity has ever undertaken. But in an irony of history, we may stop ourselves from going into space the more we do it. With every rocket launched and with every satellite deployed, we're creating a trap for ourselves that gets deadlier and more dangerous every year. If it's ever activated, it could end the space age and trap us on our planet for decades or even centuries. Getting something into space is incredibly hard. To do so, you need to move very, very fast, at first straight up to leave the atmosphere, then sideways to begin a sort of circling around the Earth, still very, very fast. If you do that successfully, you can enter a low Earth orbit. And once in orbit, it's very hard to get out of orbit. Unless you have energy to spare, you're sort of locked in here, falling around the Earth forever. That's great for things we want to stay up, like space stations and satellites. And so we moved the majority of humanity's space infrastructure to this place, just a few hundred kilometers above the surface. Just high enough so that the atmosphere is so thin that orbiting things can stay up for centuries before air resistance can slow them enough to bring them back to Earth. But this is also the source of our deadly trap. Rockets are really metal cylinders that keep big piles of fuel in place. Whenever a portion of the fuel has been spent, the empty tanks are dropped to make the rocket lighter. Some parts crash down to Earth or burn up in the atmosphere. But most of the useless rocket parts stay up and begin to orbit the planet. After decades of space travel, low Earth orbit is a junkyard of spent boosters, broken satellites and millions of pieces of shrapnel from missile tests and explosions. Right now, we know of around 2,600 defunct satellites, 10,000 objects bigger than a monitor, 20,000 as large as an apple, 500,000 pieces the size of a marble, and at least 100 million parts so small they can't be tracked. This debris is moving at speeds of up to 30,000 kilometers per hour, circling Earth on crisscrossing orbits multiple times a day. Orbital speeds are so fast that being hit by debris the size of a pea is like being shot by a plasma gun. On impact, the debris vaporizes, releasing enough energy to punch holes straight through solid metal. So, we've covered the space around our planet with millions of deadly pieces of destruction. And we also put a $1 trillion global infrastructure network right in the danger zone. It performs critical duties essential to the modern world: global communication, GPS and navigation, collecting weather data, looking out for asteroids, and all manner of scientific discoveries. Things we would miss very much if they suddenly went away. If just one pea-sized bullet hits one of our 1,100 working satellites, it will be destroyed instantly. 3 or 4 satellites are already being destroyed this way every year. As the number of satellites and the amount of junk in orbit is expected to grow tenfold in the next decade, we're approaching a tipping point. But the worst thing in space is not tiny pieces of junk. The worst thing would be an unstoppable chain reaction that turns a lot of non-junk things into junk. For example, if 2 satellites hit each other in just the right way. If satellites collide, they don't stop and fall out of the sky. It's more of a splash than a crash. Orbital speeds are so fast, solid pieces spray right through each other, transforming the 2 satellites into clouds of thousands of little things still fast enough to destroy more satellites. This could trigger the slowest and most destructive sort of domino effect, a collision cascade. Like a shotgun spray, each collision creates more bullets. What was once a single tiny target, very unlikely to hit anything, becomes a wall of destruction, hungry to make more. As more and more satellites are destroyed, the destruction accelerates exponentially, eventually destroying everything parked in orbit. But space is very empty, so the first few collisions may take a long time. By the time we realize what's happening, it's too late. 1 year, 1 satellite is destroyed, and that's no big deal. The next year, 5. The year after, 50, until there's nothing left. The situation in orbit is rapidly worsening, and we may already be past the point of no return. Within 10 years, space around Earth may no longer be viable for long-term satellites or rockets. The worst-case scenario is horrifying. A debris field made of hundreds of millions of pieces, many too small to track, moving at 30,000 kilometers per hour. It would effectively create a deadly barrier around Earth, possibly too dangerous to cross. Dreams of moon bases, Mars colonies, or space travel at all may be set back centuries. And the loss of our space infrastructure would send some of the technology we rely on daily back to the 1970s. But it might not be too late to clean up our mess. While the space industry has become better at avoiding space junk, it's still growing fast and occasional weapon tests don't help. So there have been a couple of wild but also serious suggestions about how to quickly remove as much deadly space junk as possible without creating more in the process. Lots of ideas are being thrown around, and some of the most seriously considered involve capture and return missions, which are being tested now. One method involves meeting a piece of junk in orbit with a small satellite loaded with a net. Once caught, a small rocket could be used to bring it down towards Earth. Targets too large for a net might be instead caught with a harpoon on a tether. Instead of firing a rocket, the cleaner would deploy a large sail to produce atmospheric drag and accelerate orbital decay. And there are lots of other wild sci-fi sounding proposals too. Some might use giant electromagnets. These magnetic tugs work by pushing on the magnetic components inside satellites that they use to stabilize and orientate themselves in Earth's magnetic field. These may be safer and more reliable than nets and harpoons because they never have to make contact with the junk they're handling, so there's no risk of accidentally breaking up their target into more junk. As for the tiniest bits of junk, lasers might be the key to vaporizing them entirely. Satellites with lasers wouldn't need to visit their targets, they can shoot them from far away. Large objects can't exactly be shot down, but lasers can be used to ablate them or burn tiny amounts of material off the side to push the junk to a safer orbit. Whatever technology we use in the end, we better start doing something soon, before 100 million bullets become a trillion and the trap is set. If we don't act, our adventure in space might end before it's even begun. If our days of dreaming about space exploration might be numbered anyway, we better put them to good use. One of the things we most like to spend